Good afternoon, everybody. We are here in the Auburn Hills Experience Center in the Makino Die Mold building. We are having a two-part presentation about resin and the importance of resin in the wire EDM process and the importance of resin for the water dielectric that is used in the wire EDM process. I am Mark Bay. I'm Market Segment Manager for EDM and for consumables, and I'm here with Bruce Iverson, President of Nationwide DI Water Solutions out of Elgin, Minnesota. You're going to have questions during this event, and in your browser where you're watching it, you're going to have the chance, if you go up here, there's a chat and a Q&A section, and please just use those to pose your questions. We are going to address those after the event. So DI resin in the wire EDM. 99% of wire EDM machines use water as the dielectric fluid. And the dielectric fluid in the EDM process is the fluid through which the EDM discharge occurs. The dielectric, what it also helps with is flushing away all the debris that is generated in the EDM process. So all the small particles, get them out of the cut zone, out of the EDM zone, out of the spark area, because then if they're not flushed away, then you're going to have secondary discharges. You're not going to be able to hold tolerances or get a decent finish on your part. The dielectric also keeps the workpiece cool, because we're working with electricity, we're working with a spark that is very hot. So in order to keep the temperature down, that's where the dielectric helps as well. The water also acts as an insulator that prevents the short between the wire electrode and the conductive workpiece. But it also acts as a conductor at the time of when the actual discharge is happening. There's a discharge channel that is created through the dielectric fluid, and then we have the spark and we have the EDM process. The key for this to work correctly is that the conductivity of the water dielectric needs to be just right. But what does just right mean? There are different recommendations depending on the machine manufacturer, but a good overall level that is typically recommended is 15 micron Siemens, and that is the conductivity. There are some manufacturers that recommend to run with a lower conductivity and around like 10 micron Siemens. And then also depending on what you're going to cut, there can be more stringent requirements. For instance, if you cut PCD, in order to keep the PCD itself, keep its integrity, it is really helpful to work with a lower conductivity. So we're trying to get the conductivity down in those applications to about 5 microsiemens. Some of you may also hear a different term, which is called resistivity, and it's measured in ohms or in micro ohms, and it's essentially the inverse of the conductivity measurement. So they both measure the same thing, the same quality, but they're looking at it just from two opposite angles, so to speak. What happens during the EDM process is that the conductivity of the dielectric fluid, of the dielectric water, changes. And mostly that happens through dissolving of metal salts that get absorbed into the water. That's not, that dissimilar from if you put table salt into a glass of water or into, when you cook pasta, into your cooking water, it dissolves. And that's what happens during the EDM process as well. And when that happens, the conductivity of your fluid increases. And if it increases too much, then your cutting results are going to deteriorate, your workpiece quality is going to go down, and your overall EDM results are not going to be where you want them to be. And that is exactly where the resin comes in. The resin helps to maintain your water's conductivity levels at the desired point. Now that we've covered some, the reasons and the theory of why we need resin to maintain the dielectric in the EDM process, I'd like to hand it over to Bruce Iverson, president of Nationwide DI Solutions, Water Solutions, to give us a little bit of a glimpse behind the scenes of what happens with the resin when it reaches back to the regenerator or to the manufacturer. Because as I think most of you are aware, is the resin itself it's kind of reused in most cases. So we send it to you, the end user, and once the resin life is exhausted, then it comes back to us and we hand it over to Bruce to do a regeneration process on it. So we're not throwing things away, but to keep, sort of like almost like a recycling process, I would say. So Bruce, if you can go ahead.
I'd like to thank you, Mark, for having me here today, and Makino and SST for making me part of this video on resin and how it works with the EDM machines. I have been in the business for 36 years, and we have a total of 8 employees at Nationwide DI out of the Midwest facility, and we actually have another facility in Chattanooga, Tennessee that houses product and stuff so we can ship. The main regenerations on the EDM resin, the process is all done in Elgin, Minnesota, and from there we ship back and forth from our Tennessee facility. So we've got 5,000 square feet and 2 employees in Chattanooga, which will serve the southeast and some of the east during the East Coast. That way we can help out on the freight charges and stuff.
Yeah. So how much processing can you do in a day? Let's say if we talk about a typical resin tank size or so.
We are able to do about 120 to 180 cubic feet of EDM resin per day. So it's, we have to do that to be able to keep up with the demands of the customers. So
that's a substantial amount.
Nationwide DI provides our customers with quality regeneration, the process itself. We have inventory of virgin resin for the customers that need the virgin resin for cutting certain metals. We provide exceptional customer service to our customers and our OEMs. Very important is the rapid turnaround in being able to process the product and get it back out the door as soon as possible. We have a well-stocked warehouse with DI cells and all the parts and components that go with that. And all the accessories that are needed to provide to the customers and the OEMs.
Maybe, right, some of us have seen resin. Sometimes, unfortunately, if it's spilled on the floor or something like that, or if somebody opens a resin bottle. So we kind of know what it looks like, but what does it consist of?
Deionized resin beads, if you've ever seen them or held them, they're little plastic beads they're a petroleum-made product. So there's 2 beads actually in the resin itself. One is a cation bead and one is an anion bead. The cation bead is actually regenerated with hydrochloric acid and holds the positive charge on the resin. And the anion bead is a negative charged resin that is regenerated with caustic soda.
I think something that we sometimes notice is that the color of the resin changes. Even on the new product, does it matter? Is it Does it indicate any kind of differences?
Now, we find out on the new products that you get in, sometimes people see black beads mixed in with gold beads in the resin, and the reason the black beads are all it is a dye on the resin, and it's mostly done on the cation resin. And the reason that is done in resin is for the separation. When you go through the process, you have to separate these two beads in one separation tank. And by having different colors, you can separate, and you can actually see that line for the separation. And when they're both gold, it's a lot tougher to see that separation because you have to pull one off of the other.
I think we're going to see that, right, when when you talk about like what the resin regeneration process looks like. Yeah. It's not a quality feature. It's like it really helps just for the regeneration process.
And I think a lot of customers actually if they get a virgin product in and they actually see, they look at the product and say, hey, this has got some color in it, and they right away think, you know, this isn't good resin, and it is good resin. It's just got a different colored bead in it.
Mm-hmm. What am I looking at?
This is the regeneration plant, and this is actually the steps that we take for the process of the regeneration. So we actually take the exhausted tanks from the customers that have sent in after they've been depleted and used. We take them tanks, whether it's tanks, 55-gallon drums, bags, and we have a 60 cubic foot process that we use. So we take several different customers' resin, and we'll fill, A is the separation tank. So we'll fill that with 60 cubic feet of resin, and that process goes through a backwash process, as we were talking about earlier. So that separation.
That's where you separate the cation
yeah.
from the anion.
Yeah. So the cation is a heavier resin. So the cation will always go to the bottom, and the anion will float on the top. And that's where that separation, as you're flowing water up through that backwash tank, them two resins separate, and you get a line, and that's where we take one off the other.
So why do you have to separate them in the first place?
Well, the reason we separate the anion and cation is they have to go into their separate resin vessels, B and C, for regeneration. The anion...
Do you use different chemicals?
Yes. The anion is regenerated with sodium hydroxide, caustic soda, and the cation is regenerated with hydrochloric acid, HCl. So you can't mix them two chemicals together because you don't get a good result.
Yeah. So that's where the backwash and the separation comes in.
So once the separation is done and the two are removed from the separation tank, they go into their own vessels, which then the chemical process is done in each of the separate tanks for the regeneration process. And then from there, we go in, after the regeneration process is done, we move both resins after they've been rinsed. They go into vessel D, which is a remix tank. And we mix the two resins back together, and then they can be dumped into a tank that we dump them in, and we dewater that resin, and then we can place it back into the tanks in the bags or barrels, however we're going to ship it.
Mm-hmm. And how long is the whole process? Or, you know, each step of the process?
I would say the whole process for regeneration of 60 cubic feet is between 3 to 4 hours from the start of the backwash through the chemical process of regenerating in the remix. So that's where, you know, when I said we can get 120 to 180, it all depends on how long of a day we work.
Sure. And I mean, using those chemicals, right, for the recycling regeneration process, can you reuse the chemicals, or do you need a new batch every time, or?
We actually, in our process, we actually reuse some of the chemicals in the process that we actually have set up. So by reusing some of the chemical, we're being able to save some use of new chemical, which helps environmentally, and then the cost itself for the regeneration process.
You know, also I think something that we see sometimes is if customers don't use proper filtration, or if they're cutting certain dirty materials, quote unquote, that just create a lot of like fine debris. Sometimes it may not be caught by a filter, by your regular dielectric filter. A lot of that stuff ends up in the resin itself. Is something that we've noticed. Does that come out during the backwash process as well?
Yeah.
Or, I mean, does that kind of ruin a batch, or what's the effect of that?
No, we get a lot of resin that is very dirty, depending on what they're cutting and stuff. If they're cutting carbide and stuff like that, some of the resin is really dirty, and a lot of that dirt and filth gets backwashed out during the backwash, and then whatever is left over would be part of the chemical process in the regenerating, where the chemicals actually remove them products off the resin beads.
So sort of spells out the process that we saw in the tanks before,
Yeah,
is that correct?
Yeah, I'll go through it really quick here. So the regeneration process, we kind of went through it by looking at all the vessels, but the first step would be removing the resin out of the tanks that are coming into the for regeneration. Next step would be the backwash process to backwash and separate the anion and cation, and then we go into the regeneration mode of the anion and cation separately, and then we go into a rinse mode where we rinse the anion and cation with pure water to get remove the chemicals that were part of the regeneration, and then we go back into the remix of the two, and then we're ready to refill the customer's products.
There sometimes used to be like separate resin tanks or vessels, so there would be a cation and a separate anion, vessel. Would something like this make your life easier theoretically?
I think years ago you did see some of that happening, and I think the industry has, in the most part, on the EDM machines, have gone away from the two separate tanks. I think it's just one thing is, now you've got your anion cation in one tank, and a lot of times you've got shipping issues if you're shipping two back and forth. And if you're sometimes, depending on what you're cutting and stuff, you're not going to get the quality of water through your cation and anion separate beds that you will through a mixed bed.
And I believe they also they deplete at a different rate as well.
They do, yes.
So
yeah.
Okay, so that would really just add a lot of.
Correct. Yeah.
Maybe it would make your life easier, but it's not very practical in the.
Well, and it's funny you should bring that up, because in our resin mix, in our regeneration resin mix, we do a 60-40 mix. So we do 60% anion, 40% cation, just because, as you mentioned, they exhaust at different times. So if you do a 50-50 mix, the anion's going to actually exhaust quicker than the cation resin. So it doesn't do you any good to do that 50-50, or if you're doing an anion and cation, one's going to exhaust quicker than the other.
Okay, that's good info. Also, this is maybe like going back a little bit, kind of general question about you and the company. So this is kind of the process, right, for EDM resin. Do you also handle resins for other industries, or different types of resin? I mean, resin is used not just in EDM, obviously. I think the EDM is probably just 0.00001% of what resin is used for.
Yeah, a lot of your window washers, your professional window washers and stuff, will use it for spotless rinses. A lot of your detail car shops and stuff like that will use it for spotless rinses. We do business for some of your labs and stuff that they're doing testing and stuff in the food industry.
So, back to your car wash or window washing, right? That's again, that would be a, let's say, everyday occurrence where we see the effect of those dissolved mineral salts or metal salts, right? Once the water evaporates, that's when you get the water spots, right?
Correct. Yep.
And that's what the resin takes out.
Correct.
So, in essence,
removing all the salts and impurities in that water. Mm-hmm. In the EDM world, it's very important to have the right conductivity for your EDM machines to run correctly for the operators and stuff. So that's all I have for today. And Mark?
Well, thank you, Bruce. I appreciate you coming in here today, and we'll conclude this conversation in a few weeks. We'll go a little bit more about, into the water treatment, quality aspects of your process, and also just some, practical review of what's typically out there in an EDM shop in terms of resin setups, and couple of tips also on the machine where we'll show you a few things. Thank you, Bruce, for coming in this afternoon and giving us a little bit of an overview of your company, of the process, and what you do to keep the resin running, which keeps our wire EDM machines running. So also thank you to the audience, and we'll be answering any questions that you have submitted through the Q&A or through the chat. And then we'll looking forward to seeing you again in a few weeks for the second part of the series. Thank you.